So this is 2022 Sprint Round Competition Practice 2. We're going to be looking at 21 through 25, again on the Sprint Round. So, the names of Mary's 4 children, in no particular order, are Barry, Carrie, Larry, and Perry. I think they need to come up with some better naming ideas. But anyways, the ages of Mary's children are 3, 5, 7, and 9. Oh my goodness, shoot me now. 4 kids under the age of 10? All right, Perry is not the youngest, but is younger than Barry. Larry's age is the mean of Perry's and Barry's age. How old is Larry? So right now it tells us that Perry is not the youngest, but is younger than Barry. So right now we know that Perry has to be 5, and here's why. Because we know Perry, so 3, 5, 7, 9. So we know that this cannot be Perry. And we know that Perry is younger than Barry. I think that's it. Perry is not the youngest, but younger than Barry. And then Larry's age is the mean of Perry's age and Barry's age. Well, the only way for that to happen is if Larry is in the middle, because that's the only way we can get the average to work out right. All right. 3 segments are chosen at random from 6 segments having the lengths of 2, 3, 5, 6, 7, and 10. What is the probability that 3 segments chosen can form a triangle? Well, the first thing we need to realize is that to form a triangle, you have to have a situation where any 2 sides added together is longer than the 3rd side, or else you can't close the shape. So we need to understand that. The other thing we need to remember is how to find how many possibilities there are, because we are looking for a probability. So we have 6 different sizes, and we're trying to find how many combinations of 3 we can make. Well, if you don't remember, if you have this equation, NCR, the number of combinations would be n factorial over n minus r factorial times r factorial. So how does that relate to this? Well, we have 6 factorial over 6 minus 3, which is 3 factorial, 3 factorial. Well, this is going to be equal to 6 times 5 times 4 times 3 factorial divided by 3 factorial. Well, those cancel, and then we have another 3 factorial, which is 3 times 2. 3 times 2 is 6. These cancel. So we know that we have 20 possibilities. And I should have thought ahead on that. But that's 20 possibilities. All right. So then, now we need to figure out how many of these options will actually work for making a triangle. So here's what I'm going to do. I am going to start with, if I randomly get a 2 and a 3, how many different other options are going to get me a triangle? In other words, I'm having troubles with my pens today, excuse me. In other words, a lot of trouble with my pens. Oh boy. So in other words, I will type it out. So if we have a 2 and a 3, are there any options that are less than, well, 2 plus 3 is 5. I can't have anything less than 5 or greater, and 4 is not an option. So right now, if I have those 2 things, it doesn't work. So there's 0 options. If I go with a 2 and a 5, that means anything less than 7 would work. So in that case, we have 2, 5, and 6, because 2 plus 6 is greater than 5. Sorry, 2 plus 5 is 7, which is greater than 6. All right, so then we could also go with sticking with 2. But of course, if I put in 7, 2 plus 5 is equal to 7, it doesn't work. So I can't have any others with 2 and a 5. So I could try 2 and 6, and then 2 plus 6, well, 7 plus 2 is, sorry, 6 plus 2 is 8, so that's more than 7. 6 plus 2 is not bigger than 10, so that does not work. So I'm going to get rid of this so I don't get confused. All right. So then I could have a 2 and a 7. 2 plus 7 is 11, so then the 10 would work as well. All right. So then starting out with the 3, I could go 3, 5. 3 plus 5 is 8, so then 6 would work. And that 3 and 5 and 7 would work. But 3 plus 5 is not more than 10. All right, so then I could also go 3 and 6. 3 plus 6 is 9. 9 is bigger than 7, so that works. But 9 is not bigger than 10, so that doesn't work. We're done with the 6s. We could go 3 and 7, which is 10. But that doesn't work either. All right, so there we go. And I'm in danger of forgetting one. If I do, please forgive me. All right, so then we can go start with 5. So we can go 5, 6. 5 plus 6 is 11. So 7 will work, and 5, 6, and 10 will work as well. And then we could, well, that's all of our possibilities. And then obviously 6, 7, and 10 works. So that's 3, 6, 8. So we have 9 total possibilities, and I'm really hoping that's the right answer. So 9, what number is this? Is 24. Okay, so we have 9 different possibilities. Excellent. And sorry, nine things that work out of a total of 20 possibilities. So we get 9 out of 20, but 9 and 20 don't share a factor. So we're pretty much done at this point. There's not much we can do. All right, so that is the answer to that problem. So I'm hopeful I can do the next couple of problems somehow, but we'll see if it works out. Now I have to, there we go. All right, melting the gold. All right, so let's see if, oh, my pen's working again. Let's see if it lasts. So by melting a certain amount of gold, I can make 12 coins, but no more. I might have some gold left over, and each weighing 15 grams. So 12 times 15 is a grand total of 180. So I know I have at least 180 grams. Now, if I had a little left over, but not enough to make another 15-gram coin, that means I would have 14 grams, and because we're dealing with whole numbers. So I could have somewhere between 180 grams and 194 grams and not be able to make another coin. Or I can choose to make 16 coins, and each weighing 12 grams. And so when I multiply those two numbers together, I know that I have at least 193 grams. Sorry, 92. But I could have a little bit more, right? So I could have 11 more, so that is 200 something, but I don't care what the something is. I know I can't have more than 194. So what is the amount that I can have and not make another coin? Well, if I have 194, I can make that last coin, right? So really I can't have more than 193. And so that is the amount of gold that I totally have, 193 grams. Well, 193 divided by 13, oh geez, I'm so excited to get the answer. So we want to make grams, or coins are made out of 14 grams. Well, 193 divided by 14 is approximately 13. So 14 goes into 19 once, carry the 5. 14 goes into 53 3 times, and we would get 42. So we have 11 grams left over, so 13 coins. All right. Number 22. All right, this is just a straight divisibility problem. So we have 10 factorial, and we want to know what is the remainder when we're dividing it by 2 to the 7th. Well, the best way to deal with this is let's take, we're going to take 10 factorial into prime factorization, but we don't care about all of its factors yet. We just really care about the 2's. So 10 factorial has a factor of 10, 8, 6, 4, and 2. All of these have 2's. Obviously, 10 factorial also has 9, 7, 5, but none of them have 2's because they're even. So 10 has 1 2. 8 has 3 2's. 6 has 1 2. 4 has 2 2's. And 2 also has 1 2. So how many total 2's will we have in 10 factorial? Well, 1 plus 2 is 3, plus 1 is 4, plus 3 is 7, plus 1 is 8. So we know that 10 factorial has 8 2's. Well, if we're dividing by 7 2's, if we're dividing by 7 2's, we have enough 2's to cover that with 1 left over. So we know that we're going to have a remainder of 0 because 2 to the 7th goes in evenly to 10 factorial. All right, last one. We have 3 darts thrown at the dartboard. If order doesn't matter, how many different ways can we get to 50 points exactly? All right, so here's how I'm going to do this. I'm going to look at that first, I'm going to look at the intersections, the inner pi, because they have larger numbers. So if I get a dart to land in the 30, how can I have 2 more darts that get to exactly 50? And remember, I can't have 2 darts land in the same section. Well, I need to get 20 more. So, well, I can't throw it in the 20s because that'll take me over on the 3rd dart. I can't have 2 10s because there's only 1 10 with a 1 10 section, and we know it's 3 different sections. And so I can't make, if I throw a dart in the 30s, I can't do it. So what happens if I throw a dart in the 40s? You notice how there are 2 40 sections. Well, I can't I? That's no good. All right, I can't do that either because I can't get 2 5s. All right, so erase that. How about the 35? So if I get one in the 35, I can get one in the 5 and the 10. So I could go 5, 10, and 35. All right, so that works. All right, and I know I can't get any others in the upper section. So, all right, so what about in the outer sections? Well, I could do a 20, a 20, and a 10. All right, and all right, what about 15, 15, 20? Oh, I can do 15. Oh, check this out. I could do 15, 5, and 30. I can make it work with the 30s, can't I? So I have 5, 15, and 30. And that's about it. I mean, I don't think I can get, no, I can't. So, yep, so that's it. So there are exactly 3 ways that I could get a sum of exactly 50 points.